Students, in this video, let us will have a discussion on one more important topic, conversion of continuous AWGN channel into vector channel. In this particular topic, we will be converting the output of the AWGN channel, which is mainly X of t, sum of the transmitted signal Si of t as well as the noise signal W of t into its vector form. And we all know that the input to the bank of N correlator is not only the transmitted signal Si of t, but rather it is a received signal X of t. And this received signal X of t is given by Si of t plus W of t, where Si of t is the transmitted signal set and W of t is a sample function of AWGN process W of t, which is having zero mean and the power spectral density of n naught by 2. And the output of jth correlator is the sample of the random variable xj, and which is given by xj is equal to 0 to t, that is integration of 0 to t x of t into pi j of t into dt. And for all n bank of n correlators, there is a common input, that is x of t, and each bank of correlators are supplied with the basis function, that is pi j of t. And when you taking the product and integrating over 0 to t, you will get a variable, that is random variable xj at the output of each correlator. And according to the equation that we discussed in the previous lecture, this integration from 0 to t x of t pi j of t is given by si of j plus wj, because when this x of t is represented by its vector xj, si of t can be represented as si of j, and w of t is represented by wj. Here Sij is the component of Xi due to the transmitted signal Si of t, and Sij is given by 0 to t Si of t pi j of t into dt. And the second component in the equation number 2, that is Wj, which is the sample value of random variable Wj due to the channel noise W of t. And again, this Wj is given by integration from 0 to t W of t into pi j of t into dt. Now let us consider a new random process x dash of t, whose sample function is x dash of t, that is a small x dash of t, which is related to the actual received signal x of t by given by this equation, that is x dash of t is equal to x of t minus summation j is equal to 1 to n xj into pi j of t. Basically this equation has the form x of t is equal to x dash of t plus summation j is equal to 1 to n xj pi j of t. If there is any change in the behavior of channel, the received signal which you will get is denoted by x dash of t. The actual received signal is x of t. When something happens with respect to the behavior of channel, the new received signal at the output of AWGN channel is x dash of t, which is given by x of t minus summation xj into pi j of t. Next, substituting equation 1 and equation 2 in equation 5, we got x dash of t in the LHS we have as it is. Next, x of t we know that is the sum of transmitted signal Si of t plus W of t from the equation 1 minus the summation with index j is equal to n, will keep as it is. And this xj is the vector form of the received signal x of t, which represents the vector related to the received signal x of t, and which is given by Sij plus Wj. So this Sij is a vector corresponds to transmitted signal Si of t, and this Wj is the sample value of random process W of t when W of t is transmitted, and which is multiplied by pi j of t as in the equation number 5. Next, let us simplify. Si of t I will keep as it is, plus w of t is also kept as it is, minus summation j is equal to 1 to n, and here we simplify multiplying by simply opening this round bracket and multiplying with pi j of t. So this Sij is multiplied with pi j of t, then minus a summation j is equal to 1 to n, this wj which is multiplied by pi j of t. And now again keeping the first two terms as it is, next minus, we know that summation j is equal to 1 to n Sij into pi j of t is given by the signal set Si of t, or simply the ith signal Si of t, minus we'll keep the second summation term as it is, j is equal to 1 to n wj pi j of t. And now this Si of t and this minus Si of t will get cancelled, and W of t minus j is equal to 1 to n Wj by j of t, and this is denoted by equation number 6. So now let us go back to the equation number 5, where x dash of t is equal to x of t minus j is equal to 1 to n xj into pi j of t is there. Just you compare this equation number 5 with equation number 6, so that x dash of t can be uh, made equal to w dash of t. This means the sample function of x dash of t therefore depends solely on the channel noise wt. And from the equation number 5, the received signal x of t expressed as, just see the equation number 5, the received signal is x of t. So now we have to write an expression for x of t in terms of x dash of t as well as this summation term. Just take this summation term to the left side, you will get the expression for x of t, and that is given by x of t is equal to summation j is equal to 1 to n xj by j of t plus x dash of t. And we know that this x dash of t is equal to w dash of t, that is, which is solely depends upon the noise function, that is w of t. So therefore the final equation, that is the output of AWGN channel, x of t is equal to j is equal to 1 is to n xj into pi j of t plus w dash of t. So here we expressed the output of the AWGN channel, that is x of t, which is a continuous, in terms of the vector, where xj is the vector corresponding to the x of t. So this is the discussion about the conversion of continuous AWGN channel into the discrete or vector channel.